All right, so let's take a look at question 36 from the 2024 Standard 2 paper. So we're given a diagram showing two vertical flag poles, BE and CD, set atop a sloping ground, and we can see that they're equally tall, but they're longer. One of them is placed further down the slope. We need the height of BE. So let's draw a little diagram of this. Our diagram is going to look something like this. Line here. We'll have a line here, flagpole here, flagpole here. Mine's not to scale, but that's fine. That's going to work either way. So this is 20. This is 106 degrees. This is 53.8. And this is 27 degrees. All right, well, we can use sine rule straight away to find this length. We'll just call it y. We know it's BE, but we'll just call it y. So y over sine of 27 equals 53.8 over sine of 106. So this is our non-right sine rule. So multiply both sides by sine of 27 times sine 27. So this gives us that y equals 53.8 times sine 27 over sine of 106. Now it tells us one decimal place. So my calculator, 53.8 times sine of 27 over sine of 106. Now remember to have it in decimals mode. If you have it in radians, it might mess it up. So 25.40 dot dot dot. So this is 25.4 bracket 1 dp, and this measurement is meters. So this is our answer for question 26, part A. Now, part B tells us or asks us, what is the height of the flagpole CD correct to one decimal place? Well, for CD, this is a little trickier because the shape is a little unforgiving in the information we actually know. So we know this. We know that this is Y. We know it's 25.4. We don't actually know what this is. So what we're going to do is we're going to try and find a way to get the unknown length, which we'll call DC. When you're doing a problem like this, you really just want to try and find missing lengths based on the shape. That's one of your best approaches to this kind of question. So let's see what we can find based on what we know. We know that this Y value is 25.4. We know that this top distance is 20. So let's draw the shape again. We have this distance, which we just said was 25.4. We know this distance is 20. Consequently, this distance here is also going to be 20. If we look at the diagram, we can see that there's a little right triangle down the bottom, and we can actually work out this angle. In the above diagram, the two angles here must add to 180. So one of them is 106. That means this angle must be 74. So we can actually use some trig to find this length here in the lower right triangle. Whatever the length DC is, DC must be equal to 25.4 minus this missing length, which we might call alpha. So if we find alpha, take it away from 25.4, that'll give us DC. When you do these questions, you never know what it is that you're going to have to do to get your answer. But you sort of keep trying to find angles and lengths, and eventually if you find enough, hopefully you'll have enough to give you the length you're after. So for the alpha value, we're going to use tan rule. We have tan of 74 is equal to opposite over adjacent is equal to 20 over alpha. So rearrange, multiply both sides by alpha, divide both sides by tan 74. Alpha is 20 on tan 74. So this gives me 20 over 10, 74. This is 5.7349. 5.7349 dot dot dot. Now we might round this to, let's say, 3 decimal places, because this is not our answer, but it's a number we're using in our working. So we'll call this 5.735, 3dp. The number we want is DC, so this implies DC is 25.4 minus 5.735. 25.4 minus 5.735 is 19.665. 19.665. So this is 19.7 to 1 decimal place, and this is in meters. So this is the answer to question 36. This question, incidentally, because of the rounding, they made you do 1 decimal place for part A. Now, that means you're allowed to use that number in the next question. Right? You could have done it more precisely by using the original full number before rounding. It's not actually going to matter. This question has a very unusual looking setup as well. So you could get a question like this exactly as it is in either a standard 2 paper or an advanced maths paper. It would probably be worth the same number of marks. It would appear earlier in an advanced maths paper, but it is technically common curriculum. It wasn't in the advanced maths paper, but it could have been.